Hello, I'm Vlab Cooper. This is Physics Video Laboratory Report. Kinematics is the science of describing the motion of an object using words, graphs, diagrams, equations, and numbers. As a quick review, motion graphs interpret the motion of an object to the lines and curves on a coordinate plane with x and y axis. The y-axis is the motion measurement of the object over a time interval in which time is the x-axis. Y values could be the position, velocity, or acceleration that we will use later on in our graphs. In this video, we are to use Tracker, a motion tracking program to analyze the motion of an object. We chose a situation wherein everyone could relate. Are you familiar with these? In our case, we chose the crane machine and the slam-a-winner machine, or the drop ball machine. After waiting for people to play, videos were immediately taken and uploaded to Tracker to process and analyze the data. Sadly, no one was able to win a big prize. For the crane machine, this is the position versus time graph. From the figure created from the graph, it could be observed that the crane was going down, and then it rested for a certain time, then it went back to where it started. This is the graph of the velocity versus time. As we can see, the line of best fit of the graph shows that the velocity of the crane machine is not constant, even though it's controlled by a machine. As we can see, there was a certain time interval where the crane had an almost zero velocity. This is because when the crane was trying to grab the toy, it was not moving. The reason why we have positive and negative is because the crane moved downward and upward. Remember, the positive and negative signs only determine the direction. This is the acceleration versus time graph. Maybe you're thinking that the acceleration will be around negative 9.8 meters per second squared. But I'm sorry, you're wrong. Let's go back to what I've said a while back. Yes, the crane machine is not a free-falling object. Therefore, we can't have negative 9.8 meters per second squared. Instead, this is what we get from the line of best fit. A very minimalistic increase in the acceleration. Just like the VT graph, AT graph also has a certain time where the acceleration is near to zero. For the slam-a-winner machine, in the position versus time graph, it can be observed that the line created was like a curved line, which signifies that the ball was not moving in a constant velocity. In the velocity versus time graph, it can be observed that the velocity was gradually going down up to negative 5 meters per second, and then it suddenly went back to zero. Why did it go back to zero? This signifies that the ball already reached the surface of the drop ball machine. At approximately 0.53 seconds, the ball already touched the surface. According to theory, the acceleration of a free-falling body should be constant, which is the gravitational pull of the Earth that is negative 9.8 meters per second squared. Our graph of acceleration versus time, it was not able to show the constant acceleration of negative 9.8 meters per second squared. But instead, it showed that at a certain time interval, the acceleration was negative 9.8. Why is that? Let's go back to the video. As you can see, when the ball was dropped from the top, it first hit the surface of the translucent tube before it went down. Also, when the ball hit the tube, it changed a little bit on its direction, which destroys the purpose of one-dimensional. If you only have one token left and you want it to be worthy and not wasted, I could suggest that you can use our analysis about the drop ball machine, since most screen machines have cheats. The clothes are just designs, I'm telling you. In conclusion, a simple setup consisting of a digital camera and video analysis open source was able to analyze motions of two common game machines inside an arcade center. Our analysis was able to show that Tracker could be an easier and more efficient way of analyzing motions of objects. The graphs were not exactly alike as the theoretical graphs, because the experiment was not done in a system that has no non-conservative external forces. The accuracy of the experiment was severely affected by the camera distance when taking the video. Also, maybe the Tracker was not manipulated well, because it was not easy to pinpoint the exact position of the objects from time to time. Air resistance should be neglected, and we are not sure if there was no air resistance inside those machines.